This is my video. It goes along with what you have on your paper notes. Mine just looks a little bit different because I did it the computer version. Please stop this video as you need
This
so that
lesson
you
is
can
all
fill
about
up your notes
understanding
as part of
place
your
value
classwork grade.
relationships. You should be able to say, I can use a place value chart to compare the values of different digits and justify the comparisons. So basically, you need to compare numbers and you need to prove it to me. Here's a way to spark our learning and our thinking. Some museums keep collections of insect specimens as a historic record. Experts keep track of inventory, inspect specimen cases for damage, and check that labels are set correctly. How can you show the number of beetles in the museum insect inventory? So here we have a table. We're looking at beetles, and we have this number, 1,240. Then we have wasps, 19,725, and butterflies, 11,100. So I only read this word problem once. I'm going to read it again to make sure that I understand what I'm being asked to do. Some museums keep collections of insect specimens as a historic record. Okay, that's just background. Experts keep track of inventory, inspect specimen cases for damage, and check that they're labeled correctly. How can you show the number of beetles? Okay, that's all I care about in this question, the beetles. So I have 1,240 beetles. What I can do, if I click on this is ones, tens, hundreds, and thousands. So we have 1,000, we have 200, and then we have 40. So we need 4 tens. 1, 2, 3, 4. Okay, let's check what we did. Make sure that everything's on here. So we have 1,000. Whoa, it's a mess on here. We have 1,000. We have 200s. And then I have 10, 20, 30, 40. Let's save our work. What did you use to show the number of beetles? We used face value blocks. There was 1,000 block, 200s blocks, and 4 tens rods. Please get this down on yours. Pause if you need to. We're going to skip the turn and talk because we're not talking with this. We're just trying to build our understanding using what I have to say. Now let's look at butterfly. This is called the Blue Mountain Swallowtail butterfly. It's beautiful. The museum has 11,100 butterfly specimens. Let's look at the relationship between the values of the digits in the thousands place and the hundreds place in this number. Okay, so we have to first look at the thousands place. There's a 1 in the thousands place, right? So let's get out with our little image, a thousands block. But then we're looking at the hundreds place. The hundreds place is just this little flat. So let's go back to our thing. I can think to myself, well, if I were to take 10 of these hundreds flats, that would give us 1,000. So this is 10 times, 1,000 is 10 times bigger. And that also means that this guy over here is 10 times smaller. Okay, so we're going to select the arrow to show a sample representation. You could have said that for this number, 11,100, if we put 11 or 10 of these thousands together, that would be like a really long tower of 10,000. Then we had 100, which would mean we had 1,000, which would be 1,000 cubed. 100, we would just want one flat. 10 would just be one long rod, and then 1. Why did we use each representation? Well, we know that one long is made of 10 cubes. One flat, so 100 flat, is made of 10 longs. 1,000 cube is made of 10 flats. Okay, so 1,000 has 10 of those hundreds flats. And we know that 1/10,000 long, so this long thing here is made of 10,000 cubes. Each place is 10 times bigger the further you go to the left. What did you notice about the size of each representation? So for here, is each representation 10 times the size of the previous one? Is it each representation is 100 times the size, or are they the same size? So looking here, this one, is it 10 times bigger than the one, or is it 100 times bigger? We know that they're different. Well, in our answer, we said that they are 10 times the size of each one. Check your work. It tells us we had good thinking. Let's describe the relationship between the values of the digits in the thousands place and the hundreds place. So we're going back to that original question. The value of the digit in the thousands place is, okay, so thousands and hundreds, it's going to be 10 times the value of the hundreds place. Okay, the next page. We're still talking about these insects. As many as 136,080 insect fragments could be found in the foods you buy at the grocery store. Yuck! This means you might be eating bugs. What is the value of each digit in the number 136,080? So this right here is not just one. It's worth more because of where it is in this number. Using a place value chart can help you understand the value of each digit in a number. Place value is a vocabulary word, and so is the word period. Place value describes the value of a digit in a number. Each group of 3 numbers in a multi-digit number separated by commas or spaces is called a period. Each period is going to have a hundreds place, a tens place, and a ones place. Okay, so here you'll see that we have the ones period. It goes ones, tens, hundreds. Then we're in the thousands period, so it would be thousands, 10,000, 100,000. 1 million's place, 10 million's place, hundreds millions place. What we're going to do is we're going to write in 136,080 in the place value chart. I like to start, I'm going to just rewrite the number here. You do not have to rewrite this part. But I like to start over here on the right-hand side. So with the number 0. Well, 0 goes in the ones place, 8 goes in the tens place, 0 goes in the hundreds place. The comma goes in between each period. 6 goes in the ones place, 3 goes in the 10,000s place, and whoop, 1, wow, oops, 1 goes in the 100,000s period. Hundreds, thousands place. I'm going to save my work. Here's a correct place value chart. It looks just like ours. So let's answer the question, what is the place value position of the digit 6? So looking at this number chart, 6, is it in the ones place, the hundreds place, or the thousands place? Well, it says ones, but it's actually in the thousands period. So this is worth 6 thousands. How can you find the value of the digit 1 in 136,080? Okay, so using the place value chart, what I can do is look at where the 1 is, and it's in the 100,000s place. So it is worth 100,000. I'll stick this down and I'll show you how I know that. Because this 1 is here in the 100,000s place, if you're ever asked to show how you know, well, I put the 1 and everything after would stay a 0, just to show it's in the 100,000s place. Let's write other ways to find the value of the digits in this number to complete the place value chart. Okay, so we have the number rewritten here. Why don't we start over here? You know what? Let's always start from the right-hand side in the ones place. We don't have any ones, so we have 0 ones, which means this is really worth 0. How many tens do we have? Well, we have 8 tens, so this is really worth 80. We don't have any hundreds, so this place is worth 0. Okay, so here we have 6,000. And the way we write that is 6, 3 zeros afterwards. Everything after would be a 0. 3 10,000s would be written as 30,000. And 100,000 would be written as 100,000. Let's save our work. This here shows you the correct answer, just like I wrote it for you, but what the book shows you. So what did you notice about the value of each place in the place value chart? Looking at this place value chart, ones, tens, hundreds, thousands, 10,000s, 100,000. Did you notice the value of each place is 10 times the value of the place to its left? Is it that the value of each place is 100 times the value of the place to its right, or the value of each place is 10 times the value of the place to its right? This is difficult if you have a hard time remembering what is left and what is right. This is left and this is right over here. Okay, your hand on the left makes an L if you were to hold it up. So the value of each place is 10 times the value of the place to its right. So here, the tens is 10 times that of the ones. The 10,000s is 10 times bigger than the 1,000s. So this is the correct answer. This is how numbers work all across the world. Each place, every time you move up, is worth 10 times more. Let's step it out. Now we're looking at bees, actually yellow jackets. Yellow jacket wasps live in colonies that can contain up to 15,000 wasps, while bee colonies can have as many as 50,000 bees. Oh, okay. I'm going to highlight both of these numbers just so I remember to pay attention to them. How does the value of the 5 in 50,000 compare with the value of 5 in 15,000? So we're going to use the place value charts to compare. Step A, let's show 15,000 in the place value chart. Okay, so let's take out our pen and we're going to show 15,000. Notice that I use a comma in between these two periods. So here's the period line, right? We have the ones period, the thousands period. So I write a comma in between the 15 and the zeros. Let's save our work. Here's it completed by the book, just so you can see what yours should look like. The 5 in 15,000, the value of that number, is it worth 50? Is this worth 500 or is it worth 5,000? Well, you should know it's worth 5,000 because it's in the thousands period. So now for letter B, let's show 50,000. 50,000. Let's save our work. Here again, it's just showing you how the book completed it. So looking at the 5 in this number, even though both numbers are 5, it has a different value because it's in a different place. So this 5 is really worth, is it worth 50,000, 5,000, or 500? This is in the 10,000s place, so this is worth 50,000. So which 5 has the greater value? Is the 5 in 15,000 worth more or the 5 in 50,000? Well, it's the 5 in 50,000, right? We know that it's worth more because it's in a higher place. Letter D, let's complete the statement. The value of the digit 5 in 50,000 is how many times the value of the digit 5 in 15,000? Okay, so let's remember what I said about numbers. Each place, I'm going to write it up here in pen for you in green. Each place is 10 times bigger when you go this way. So 100 is 10 times bigger than the tens, so on and so forth. It's worth 10 times more. So the value of the digit in 50,000 is 10 times the value of the digit in 15,000. When you go from one place to the next one, from left to right, from right to left, it gets 10 times bigger each place. Okay, that's the end of this lesson, our first lesson. I want you to think about the I can statement I gave you at the beginning. Do you feel you can use a place value chart to compare the values of different digits and justify those comparisons? You have to remember that each place is 10 times greater than the one before it. This tens rod has 10 ones. This hundreds has 10 tens in it. Each place is 10 times greater than the one before. Nice job, guys. Make sure you save all your work.